Hey guys, Mr. McKinney here, just going through our videos on LHopitals Rule, which has to do with limits. So let's start with a review of limits. A limit is asking what value the function is approaching as x approaches a certain number. Now, if a function is continuous, the value of the function and the value of the limit are always going to be the same thing. Where the problems will get more interesting is if the function is not continuous for some reason, or if you have an asymptote in play. So the first thing you should always try is to just plug the number in and see if you get an answer. So the limit as x approaches -4 of 3 plus x squared, the first thing I'm going to try to do is just plug in -4. So 3 plus -4 squared, 3 plus 16 is 19. As soon as I have plugged in the number, I don't need to write limit anymore. So I don't need a limit statement here or the rest of the way. The answer to this one is just 19. So in your head, just think about if you can plug the number in. And if you can, if you don't get any problems like divide by 0 or square root of a negative, then you're done. Now what this is actually asking is if we graph the problem y equals 3 plus x squared, so an x squared graph shifted up 3 units. When x is -4, what y value are we approaching? Since this is a continuous function, the point -4, 19 is on the graph, which means that 19 is the limit as x approaches -4. So the first thing you should always do is just plug the number in, because if it doesn't have any issues, you're done, and just box your answer. All right, so hit pause, try to do these three as quickly as you can without a calculator. All right, let's see how you did. So first one, limit as x approaches 3 of pi. So this is like the graph y equals pi, which would be a horizontal line at pi. So my answer is pi. All right, limit as x approaches pi over 4 of sine of x. That's the same as sine of pi over 4, which is √2/2. You don't have any issues here, so you can just do that one straight off the bat as well. Now this one, some of you guys are like, without a calculator, how am I supposed to do this one? But there is a trig identity that says sine squared plus cosine squared is 1. So this is really the limit as x approaches -42.347 of 1, which is 1. You're graphing the line y equals 1. Doesn't matter what x value you're approaching, the answer is always 1. All right, so this was going back to last semester, just basic limits, evaluating them, and a lot of times you can just plug the value in. Now, sometimes you can't plug the value in. So if I plug in 3, 9 minus 9 is 0, 3 minus 3 is 0. First of all, do not write equals 0/0. Off to the side, you can write 0/0, that's fine. But if you say equals 0/0, you're going to lose credit on the AP exam because 0/0 is undefined. And this ends up being defined. It has an answer. And if you say that it's equal to an undefined value or an undefined function, you will lose your credit. So don't say equals 0/0. Don't say equals infinity over infinity. On this particular problem, when we ran into it last semester, we could handle it by factoring it. So we'd rewrite it as the limit as x approaches 3 of x minus 3 times x plus 3 over x minus 3. And then I could cancel these out. So it's the same as the limit as x approaches 3 of just x plus 3. Then I can plug in 3, so my answer would be 6. So I don't want to say this equals 0/0 because that's undefined. And this limit exists. The answer is 6. Visually, it would be, we would think about this function would be graphed, y equals x plus 3, so up 3, and then we're graphing that function. But there would be a hole at x equals 3 and y equals 6. So at 3, 6, there would be a hole. That function is not actually defined. So if this was my f of x, if I made that f of x, f of 3 is undefined. But the limit as x approaches 3 of f of x is 6. Because as I approach 3 from either direction, from the left or the right, the y value is approaching 6. So back in the very start of the year, we handled problems that gave us 0 over 0 by factoring them. And that's fine. Some problems can be done that way. And this is just graphically looking at what we were talking about there. So you got your hole up there. Okay, now some problems cannot be manipulated using factoring or any of the other tricks. So sine of x over x, if I plug in 0, sine of 0 is 0 divided by 0. 0 divided by 0, we don't know what that is. And there's no easy way to factor this. Same idea over here. You'd get 1 minus cosine of 0 is 1. So 1 minus 1 is 0 divided by 0. So some problems can't be handled with factoring or multiplying by the conjugate or any of the other tricks. So if a problem can't be handled with some of the tricks we already learned last semester, if you get 0 over 0 or infinity over infinity, you can use what's called LHopitals Rule, which was LHopital is a person who gets credit for it, but actually Bernoulli invented it. I'm not going to get into the details on that. Reach out to Mr. Janssens if you want the backstory on that at all. This is LHopitals Rule. Make sure that you star this in your notes. This is a really important part. It's going to show up on the AP exam somewhere. And if it shows up on the free response portion, you have to write the correct notation. So basically, LHopitals Rule says if you're trying to find the limit of a function and the limit on the top, so the limit as x approaches c of f is equal to 0, and the limit of the bottom, so the limit as x approaches c of g is 0. If both of these things are true, then the limit of the original problem is the same as the limit of f prime over g prime. So again, this only works if the limit on the top is equal to 0 and the limit on the bottom is equal to 0, or if they're both infinity. But if that's the case, then you can say that the limit as x approaches c of f over g is the same as the limit as x approaches c of f prime over g prime. Now note that if we didn't have any limits in here, if we were just saying f of x over g of x is the same as f prime over g prime, this would be 100% wrong. This is not true. If I wanted to do the derivative of this, I would need to use the quotient rule. So don't just take the derivative on the top and the bottom. You would need to do the quotient rule. This is different than the quotient rule. All right, now let's do some examples so we can get an idea of how this applies in calculus and what we need to write out on the AP exam to make sure we get full credit. So yeah, they can either both be 0 or they can both be infinity, whether it's positive or negative infinity. All right, so the limit as x approaches 0 of sine of x over x. If I plug in 0, I would get 0 on the top and 0 on the bottom. First of all, do not write equals 0 over 0. You lose credit if you write equals 0 over 0. Off to the side, you might write 0 over 0 just to remind yourself of what you're doing. But I wouldn't even worry about that. I would do it in my head, and then once I recognize that it is 0 on the top and the bottom, I have to write out the limit of the top equals 0 and the limit of the bottom equals 0. And because both of those things are true, then I can take the derivative on the top and the bottom. So I'll show you what you would need to write on the AP exam. So if this was the problem on a free response question on the AP exam, there's 3 things that you always need to write. So first, you need to write the limit of the top. So you would say the limit as x approaches 0 of sine of x is equal to 0. Then you need to write the limit for the bottom. The limit as x approaches 0 of x is also 0. As long as these 2 statements are both equal to 0 or both equal to infinity, then you say, therefore, LHopitals Rule applies. Now you can write it out with all those words, or you can just say, therefore, LHop applies, or therefore, LHop. 3 dots is another way of saying therefore. So you have to write this part out first. So one thing is the limit on the top. Second thing is the limit on the bottom. Third thing, you need to reference LHop somewhere. So therefore, I'm going to use LHop. Therefore, LHop rule applies, something like that. So now I can say that this is equal to, I still need the limit statement, and then instead of sine of x over x, I'm going to take the derivative of each of these. So the derivative of sine is cosine of x, the derivative of x is 1. Because these things are true, this limit is equal to this limit. So now I'm going to plug in 0. Cosine of 0 is 1. 1 divided by 1 is 1. So this limit, which was undefined, it was like 0 divided by 0. In this case, 0 divided by 0 turned out to be 1. Sometimes 0 divided by 0 ends up being 1. Sometimes it's 0. Sometimes it's infinity. Sometimes it's 7. And we'll see a lot of different examples. All right, let's go through this other one that we referenced at the start. So cosine of 0 is 1. 1 minus 1 is 0. 0 divided by 0 would be undefined. So again, don't write equals 0 over 0. Once you recognize that you're doing a limit that has 0 over 0, you want to use LHopitals Rule. So you have to write out the limit statement on the top and the limit statement on the bottom. And you have to show that they both equal either 0 or infinity. So limit as x approaches 0 of 1 minus cosine of x is 0. You can write 1 minus cosine of 0 equals 0, but you can skip that step. You just need to show that you thought about the limit and you know that it's equal to 0. And you thought about the limit on the bottom, and that is also equal to 0. Then I can use LHop. So on an LHop problem, LHopitals Rule, make sure you use all three of these things. So you have to write the limit for the top, write the limit for the bottom, and then say, therefore, LHop applies. Or therefore, I'm going to use LHopitals Rule. As long as you have LHop or LHopitals Rule somewhere, you're going to be fine. When you write equals, make sure you still have your limit statement. Because until I plug this value in, it's still a limit. Because the limit on the top and the bottom were both 0, and I'm using LHop, I'm going to take the derivative on the top and the bottom. The derivative of 1 goes away. The derivative of cosine would be negative sine. So the derivative of negative cosine is positive sine. And then the derivative of x is 1. Now when I plug in 0, I get 0 divided by 1, which is 0. So I started out with what would have been 0 over 0. Since that's indeterminate form, I don't know what that is, I have to use LHopitals Rule. On this problem, 0 divided by 0 ended up being 0. But on this problem, 0 divided by 0 ended up being 1. So you don't want to write equals 0 over 0 because that's considered indeterminate form and you don't know what that's equal to. All right, let's do another one. So if I plug in 0, 7 times 0 is 0, sine of 0 is 0. 7 times 0 is 0, so we got 0 over 0. So now I have to write out the limit statement on the top. Limit as x approaches 0 of sine of 7x is 0. Limit as x approaches 0 of 7x is 0. Therefore, LHop. Write out all three of them. I know it's obnoxious, but the AP exam made a big deal about this a few years ago, and a lot of kids lost credit because they didn't write out the three statements. So please make sure you write out the limit on the top, the limit on the bottom, and then reference LHop. So this would be the limit as x approaches 0. Derivative of sine of 7x would be cosine of 7x times the derivative of 7x, which is 7. The derivative of 7x is just 7. So I could cancel these 7s out, plug in 0. So cosine of 7 times 0 would be cosine of 0, which is 1. We get 7 divided by 7, which is 1. All right. Let's see if we can squeeze one more in before time runs out. Actually, I don't want to rush it. So I'm going to go ahead and pause it here. We'll pick up here on the next video in the LHop series.